All right, excellent. Well, thanks again for having me. So yeah, my talk today is it covers a range of topics. There's some overlap with the other talk, which was great, just about some technologies that we use at my company, and then just a couple of slides of just sort of observations as a software engineer and some trends therein. And here's sort of the overview about me, about my company, some of the clients that we work with, technologies we use, a couple applied examples, typical developer setup, just to kind of give you insights into like how our team works, quick slide on our process, and then answer any questions you may have. So about me, again, my name is Nick Maloney. I am a Bentley CIS grad. I think it was in 2008 I graduated, dating myself a bit here, but really enjoyed my time here, learned a ton, and it's been so valuable in my career. I've been a software engineer my entire career. I've been a developer, engineering manager, and functioned in CTO roles as well. Most of my experience has been in the healthcare and wellness vertical, but I've worked in a lot of other industries as well. I started my career building real estate systems using PHP and JavaScript. I'm still heavily involved in day-to-day technology and software development. I don't sing as much code as I like, but I still do as much as I can. I love learning new languages and just staying abreast of upcoming trends. I've been really into like the Crystal language lately. That's like my sort of hobby project. I'm a big proponent of open source technologies. I use Linux and pretty much any other language that is in the open source ecosystem. Outside of work, I do enjoy like combining my passion for technologies like with other hobbies, like designing stuff in CAD and making it like on my 3D printer. Here's a quick slide of that. This is just like my basement makerspace. But I think it aligns with, as software engineers, we must constantly be learning new trends and techs in the industry. And even if that's outside of the realm of what you do day to day, if you can combine that with hobbies and other things you enjoy, it helps in that aiding process and makes it more enjoyable. It's kind of a nice break to do something that's not tied to work, but still, teaching me new things. So I co-founded the Nar Company. That's where I currently work in 2015 with a colleague of mine from our previous company. We both got laid off and didn't want real jobs. So we figured we should start our own company instead. We build custom web and mobile software using open source technologies for a range of clients and industries. We have a strong focus on best practices and agile processes. We're currently at about 30 folks, maybe just under. It deviates. Sometimes we'll bring on a contractor or two, but mostly software engineers. We do now have a design studio, and we also have some support staff. So like QA, HR, hiring, biz dev, those types of roles as well. As of 2020, we're fully remote with staff all over the USA. Prior to that, we had an office in downtown Boston where everyone worked out of. But since then, everyone's remote, and we're going to stay fully remote forever. And our team skews more on the experience side, just because of the nature of our work, and our projects are pretty complex. So I ran the numbers, and I think the average level of experience across our team on the engineering side is about 8 years, which is atypical for a newer organization, but it's worked well for us. Some of our clients are the Commonwealth of Mass. We do a ton of work for state of Massachusetts. Whoop, who makes a fitness band, they're a big client of ours. We love them. They're Boston based and just doing super cool stuff. We work with Fitbit, Johns Hopkins University on a really cool wellness app, University of California on a system for reserving their portfolio of natural resources, big tax aid application for AARP. And we've done a lot of work for EasyCater, who's another great Boston-based firm. We use a range of technologies, some more than others, and I'll dive into our core tech, but I'd say across our suite of applications, this is most of them: JavaScript, TypeScript, React, Node, Next.js, Ruby Rails, Python, Golang, and even some Phoenix and Elixir. It has been known to happen here and there. So of those tech stacks, some are fairly niche and really cater to specific computing needs. Like I'd say Phoenix and Elixir falls into that space where it's really good for like high performance sort of real-time interactions, but well, it can be used for general purpose stuff. It tends to be more niche. And a big part of what we do is just have a good understanding of the tools and make sure that we're selecting the best tool for the job, because there are, some technologies that do things better than others. And we like to have awareness into that. And just as software engineers and as you're leveling up, I always recommend to learn like the fundamental in ubiquitous technologies first. And this was touched upon in the previous talk about the dynamic between being a generalist versus specialist. And throughout your career, you want to gravitate towards not only what interests you, but what you're good at. In the consulting space, we kind of need a range of knowledge across different projects, where when you get into building a product, like Spotify is a great example, you need really deep specialization, like whether it's data analytics or even UI UX, and everyone's different, but I do recommend if you're able to like explore both areas and kind of find what you really like and what interests you. I'm going to talk a little bit about our core tech stacks that we use at the NAR primarily, and I think as of today, you'll see a lot of these in the industry. It's not to say like this is the most popular in everything, but these are what we see a lot of, and worth mentioning. So, and we do full stack development, and I put a little footnote on here just for what that is. So it's the entire depth of a computer system application. So you have the back end and the API and other interactions, but you also have the front end, what you see rendered on your screen or on your phone. And these cater to that. So, JavaScript and in the JavaScript ecosystem, then React on the front end and Ruby on Rails. And if there's any questions too along the way, please feel free to jump in and ask them. So JavaScript, like if you're working on the web, is definitely a technology that you should be familiar with, and I'm sure many of you are. I'd say not arguably, it is the most ubiquitous technology on the web. Like in this day and age, every website is running some flavor of JavaScript. You should know it. It's a building block behind many front end and back end frameworks. And it runs on everything from servers in the cloud to bare metal to web browsers on your phone and mobile devices and laptops, and even like IoT devices are built a lot using JavaScript SDKs and toolkits. The language semantics and tooling have advanced considerably since the Web 1.0 days. When it first came out, it was kind of an add-on that you'd sprinkle on to your web app for animations and form validations. But you wouldn't build an app exclusively in JavaScript, where now you will, in the language and tools have just expanded so much. It's mind-boggling for me to think through what JavaScript was like 10 plus years ago and where it is today. And with all those new additions to the language, understanding those advanced concepts really will help you be a better software engineer, even beyond JavaScript. So like closures, functional programming concepts, declarative versus imperative programming, which spans different languages. A lot of the work around promises and asynchronous concepts, which has been introduced in more recent versions of JavaScript. And this goes for anything, just understanding like the platform itself and like the runtime idiosyncrasies, like what you can do on a browser versus what you can do with V8 Node, on the back end. There's some slight differences, and you'll encounter a lot of those. So being knowledgeable is super, super helpful. TypeScript is another technology we use a lot. It's a strongly typed flavor of JavaScript, or syntactical superset. It came out of Microsoft, and the architect was Anders Hellsberg, and he's actually the architect behind C#, which is also a great language, and I think gave it a lot of credibility too. Just super well thought out, well supported. We really like it. It helps us when we're working on large projects with multiple contributors. It just makes it easier and less prone to bugs by layering on that type safety and structure. It prevents you from doing things you didn't intend to do. So perfect example is when you're passing in arguments and you can specify a type, the object that you're passing in, versus an arbitrary object, but that doesn't have a type definition. You get so many bugs that way, and you can unit test your way out of it. But by having type safety, you're much less likely to do things that you didn't want to do. Also makes refactoring much easier, especially if you're using an IDE like VS Code, because of type safety. The IDE is aware of the structure of your objects, so you can much more easily like rename things and refactor. And it's super flexible because it runs on both the front end, transpiled to JS, and the back end. You can use it across the board within your organization, and so the knowledge transfer is great, where different teams can all speak the same language, so to speak. NodeJS is another technology that we use a lot, and yet again, part of the JavaScript ecosystem. It's just a runtime that allows JS to run on mostly servers as opposed to your browser. So if you know JavaScript, you know Node, so that it has that going for it. And you'll see a lot of folks that maybe start out on the front end and then evolve into developing back-end code using Node because they already understand JavaScript. In Node, it's almost always used for building out things like API services, or like a lot of AWS Lambda functions are built in JavaScript, and in Node is a runtime. Has a huge ecosystem with a lot of libraries, frameworks within, and there's a lot of web frameworks that are built on top of Node, that just give it some structure for how to build out your app. Some of the more popular ones are Express, which has been around for a while, but super flexible and powerful. Next.js, which is a relative newcomer, and we're seeing a lot of movement there, and that's proven to be a really good Node-based framework to keep your eye on, and it does a good job of combining Node and React. And then Loopback's a bit older, but I guess that's more of like the enterprise-y flavor of some of the Node frameworks, and there's probably 50 others, but these are some of them that I tend to see a little more than like Koa and some of the others. There's a lot of fragmentation there as well. Nothing wrong with that, but just being aware of sometimes you want to choose more mature technologies than niche, because as you're building teams and needing to scale, if you have a framework that has less adoption, it might get abandoned, and there's a lot of risk associated with that. So at my company, we tend to gravitate towards projects that have a velocity behind them, so that a couple of years from now, our client's not stuck holding the bag of a project that was built with something that went by the wayside. And then Nodes on the back end. On the front end, we do a ton in React. React's a JavaScript library for building user interfaces. It came out of Facebook. I'm pretty sure it was first used to build out the interface for Facebook Messenger on the web app. And now they use it for tons and tons of stuff, as does pretty much every other company in Silicon Valley is probably using React at this point. But it's primarily used for building complex single page apps using a declarative functional concepts. All your components are built using JSX, which is kind of like HTML, but a little different, and allows you to heavily customize it. But I really like it. It's super declarative, where you can look at JSX and have a pretty good understanding of what the components do and how they're architected. And one of the things that we really like about React is it allows you to decompose your components and break that work up so that your team can collaborate on a really complex screen, but not be bottlenecked. So let's say you had a map with a form filter, someone can work on the map component, someone can work on the form filter, and then you can marry them together pretty easily, just by virtue of how components are architected. It has a massive ecosystem behind it, more so than any of the other UI libraries, and they're all great, but nothing pales or comes close to React. For things like state management using Redux, some of the routing options, things like that. Another reason that I believe React has become so popular is it's agnostic to what your backend is written in. So if you could have a company with a Java backend, Golang, C#, it doesn't care, as long as you're delivering JSON over the wire. it can parse it and you can write a React app. So that's been a huge driver of it. So I'd say in terms of like hireability as a front-end software engineer, if you have React JS, you'll have a job tomorrow. Just such a huge demand. We can't hire fast enough for it. And I think the same can be true for pretty much any company that's using React. And another part of the React ecosystem is what's called React Native. And that allows you to build truly native mobile applications using React. And that also came out of Facebook. And we really love it. I would say in 90% of use cases where you want to build a native app, React Native is the way to go, because you can have one code base and have both an iOS app and an Android app that are almost indistinguishable from a truly native app, but you don't need to invest in having someone know Swift and someone know Kotlin on the Android side. There are some exceptions there where if you need access to the low-level hardware, like GPU, so you won't see games written in React Native, but for most things, you'll see it. Like Airbnb, I think, is one of the prime examples. I think they're mostly React Native, and a lot of other major companies. Facebook obviously uses a ton of it because they invented it, but we're huge fans. So yeah, as you saw, those slides were all about JavaScript. As I mentioned, you can work your entire career in JavaScript on the front end and back end and have a great run. But I think with all that being said, like learning other languages, even if you don't do that in a professional capacity, will help you level up as a software engineer and help introduce new concepts that might not be in JavaScript, but could inform your architecture and your way of thinking, like immutability, functional programming concepts, things like that you might learn from some of the more esoteric languages. And speaking of that, another really popular framework and one that we use quite a bit, particularly on the back end, is Ruby on Rails. So Ruby is a dynamic language with a focus on simplicity and productivity. It's really easy to learn and use. It's my personal favorite language. I just find it to be so expressive, and I don't even need to bring up the docs anymore. If I just have a itch I need to scratch or a script, I can just knock it out in Ruby and get it done. It's so great like that. It was developed by a developer over in Japan named Matsumoto, and his goal was to build a language whose core focus was developer happiness, and I think he's done a really good job there. And this is going back 20 years ago when he first started, and he still really held true to that mantra. And everything's an object in Ruby, which is kind of fascinating, and it has a lot of origins and like small talk and in some of those languages, but it makes them more mainstream and approachable than some of the, I think small talk, I wouldn't say it's purely academic, but it never got widespread adoption where Ruby did. And latest version, Ruby 3, supports type safety. So I see that similar to what's happened in the evolution of JavaScript with TypeScript and all the benefits of type safety. With Ruby 3 getting those declarations, I think will help us out a lot, because sometimes dynamic languages can be a foot gun with complex projects and not having that. So with Ruby on Rails, Ruby is the language that you use, and Rails is the framework. Rails is the framework that sits on top of it. So it's a MVC, Model View Controller Web Framework. Its batteries included, meaning it includes a lot of libraries that you'd use for most web tasks, like database, schema migrations, routing, rendering, things of that nature, where other languages, Express.js is a great example, don't include any of that. So you get paralysis in what you want to use. And you have to make all these choices, where what I like about Rails is it makes those choices for you, and just has a strong focus on best practices like test-driven development, behavior-driven development, dry, which is do not repeat yourself, and then convention over configuration. And despite being fairly old, it first came out in 2007, it's done a great job of evolving. I think we're up to Rails 7 now, and it's still introducing a ton of really new novel concepts and technologies. Stimulus.js and Turbo Streams just came out, and it's it's incredible. I've been so impressed with how well it's kept up with just the shift in technology, and use it a lot to this day. Day to day, I still work a lot in Rails. And this kind of reiterates a lot of the points that I brought up. The established convention means all Rails apps are structured very similar. So I can take any one of the Rails engineers on my team and plug them into another project. And on day one, they know how it's structured, how migrations are run, all that stuff. Where in other platforms, there's a learning curve and each project's set up a little different way. So I really like that consistency. It's proven to be really rock solid and reliable. We have apps that have run for 7 years and they're still operating fine and easy to work with. Having fewer dependencies because they're part of the framework reduces risk, whether it's security risk or the risk of someone abandoning that library. You don't have to worry about that. And because it includes so many things, you can just focus on building out your API. You don't have to think about other aspects of the development and rote tasks like routing and validations are all built in. It pairs excellent with React. So we have a lot of projects that are written in Rails on the API side, but then we have a React front end that hits the Rails backend. And as I mentioned in the previous slide, Stimulus.js, which is a JavaScript library, I've really been digging that with Turbo, which is coming out of the Rails ecosystem, is like sort of breathed, I wouldn't say new life into it, but it really keeps us Rails folks engaged in continuing to use the platform. And this just kind of summarizes it, and this was touched upon in the last presentation too, is there's really no right or wrong language. Like at my company, we try to balance like technologies that we enjoy working with a market demand for our services. But you can't go wrong with learning any of the major languages, whether it's Kotlin, C#, Python, Golang, Swift. There's work for you, and just understanding what domains attract those languages can help inform what you decide to learn in your career. But the only constant as a software engineer is change. So it's super important to stay abreast of industry trends. I found you almost have to reinvent yourself every 5 years in terms of what languages you learn, because that's generally the life cycle, sometimes longer, sometimes shorter, but it's so important to be able to teach yourself new languages and just adapt with the marketplace and trends there. So never get too tied up and argue over what language is best, because it's just a matter of time to something newer and better comes along, and just know its strengths and weaknesses. And once you learn a couple languages, learning a new one becomes much easier. Like I mentioned earlier, I've been dabbling a lot in Crystal, and that was heavily influenced by Ruby. So that's what I love about it, is all my knowledge in Ruby is so transferable to that, but it introduces some really cool new concepts, which I like and have my eyes on. And the same can be said for dozens of other new languages, frameworks. Just get in the habit of trying them out, even if you don't do anything real with them. Super important. And I think last is like you'll likely spend more time reading code or in meetings than you will writing code. And it's a good skill to practice. Like if you're ever curious, like go on GitHub and check out some projects you use, even if they're languages you're not familiar with. You'll learn a ton. And that's the great thing of open source, is all that code is there for you to look at and poke around underneath the hood and even contribute to, if that's something that you'd like to do. I'll just briefly touch upon this because it kind of glues together some things. This is an applied example of a project I'm on for the Mass Department of Early Education. It's a criminal background check system and something that I'm working on. I was actually working on it today. It runs criminal background checks for all childcare providers in Massachusetts, and it does like an FBI background check, criminal background check, sex offender check, and Department of Children and Families. And those are all different systems and different APIs, and this collects all that data, puts it in a consistent format, and then lets folks that work for the childcare services review these people and make sure that they pass a criminal background check. And just tons of integrations with other state and federal agencies. Really fun project to work on the technical side, but that's all Ruby on Rails on the back end with some other microservices and like say Golang. Stimulus on the front end. We use a lot of PostgreSQL on the database side via RDS on AWS, orchestrated on AWS Elastic Beanstalk. Elasticsearch is how we power a lot of like the backend search. And then we use a lot of the AWS tooling, SQS, SNS, SES. AWS has a ton of acronyms, and I'm just throwing stuff out here. Don't expect anyone to know that, but you'll learn and hear about a lot of this as you engage more in the industry and work with AWS. And a huge fan of that platform. We use it extensively. I didn't get a chance to put up the vanity diagram on this, but another example is we're doing this big project for AARP for tax rebates, where every state has their own form. So we have to build this framework for building out these complex forms catered to that state. And front end is in React. We're using RxJS, which is an event library for React for managing all the event states within that. And then similarly, we have Ruby on Rails on the API backend. We just found it plays great with interop with other API. In PostgreSQL, we pretty much use that across the board. I absolutely love Postgres and recommend everyone learn it and be comfortable with it. You see it everywhere. So great skill to have, open source too. And I think not only does it hold its own, I think it's better than Oracle by a long shot. And we use Auth0 for user authentication. Threw this one on here just to kind of show how we work. So most of our team uses Mac. Some of us, myself included, use Linux. This is actually my workstation. I'd say 60% of the team uses VS Code. I like VS Code. About 40% of folks use Vim. Definitely recommend you use Vim because it's not if, it's when. You have to SSH into a server and fix something. And Vim is on pretty much every server. So it's just such a great skill to have. Super transferable. Everyone works in the terminal, either Bash or ZSH primarily. We all use Git, mostly on GitHub. So that's a super, super important skill to have. All our comms happen via Slack, all our emails through Gmail, which is pretty common. And then we use G Suite for everything, docs, slides. This was written in G Suite. Just to touch upon like our process. So if we're working on a new feature, we use Jira a lot for managing the tickets. We'll read the requirements, and then we're big proponents of test-driven or behavior-driven development. So once we have an understanding of the requirements, we'll actually write a test that describe what the software should do. And then we'll write the code that satisfies that test, and then refactor is needed. And once we get it to a state that we like, we'll commit it in Git and then do what's called a pull request. And that just pushes it up into GitHub and allows our team to review our code and make sure that it doesn't have any bugs. We're following conventions that we've established in the project in the company and provide feedback in a friendly, helpful manner. We may respond to it. And then once the PR is approved, it gets merged and then deployed out to the appropriate environment, and all that's specific to a project. So it could automatically deploy to QA, UAT, prod environments through AWS, Azure, whatever is on the back end. And I had mentioned earlier, we're big proponents of agile process. So the way that gets executed is like every day we have a scrum where we talk about what we're working on, any blockers, any questions. And if there are some questions that come out, we'll have a breakout session. And this is all very common. This is typical agile process where we'll nerd it up in the breakout session, and maybe we'll decompose a data model or walk through a gnarly integration or something like that. Then other times we'll do sprint planning where we'll plan what we're going to do next in future sprints. We'll do sprint grooming where we walk through the tickets and make sure that we have an understanding of them. We'll point them, meaning we'll add a number that indicates how complex it is, and that will inform how long it'll take us. And then at the end of every sprint, and again, this is all very common, we do what's called a retrospective, where we talk about what went well for that sprint, what could be improved, and any ideas that could be implemented in upcoming sprints. And that's everything. I know I covered a lot of material there, but wanted to balance framework stuff with what we do.
First question for Nick. I will ask you a question.
Sure.
If we were to teach our first course in web development at Bentley, what would be the most accessible and most important things to put in there? And obviously, in addition to a little bit of HTML and JavaScript.
That's a good question. Because there's definitely fundamentals like to take to step backward, rather than just on the language side, just like what's MVC and multi-tier application, just to like so folks understand what they're building. But then to take it from there, probably keep it in JavaScript and probably have a very simple node backend that sends information to the front end and maybe have them build it out in React, just because that's typically what you'll see, and very transferable knowledge, and it's kind of the fundamentals of what it is we build. But then do everything in JavaScript, and then you get a twofer. You get folks learning JavaScript, but then get to see that they can apply it on the front end and the back end and gravitate towards something of interest.
Before 2015, was learning or finding your own engineering something you ever really considered or consider yourself doing?
Yeah, I mean, it's something I always aspired to do, but the timing will never be right in most cases. But like I was never in a position where I always had a cushy engineering job. So like, why would I take that risk? And I think it was the first time where like I was at a point in my life where I could take that risk. And it was scary at first, especially like the first 3 or 6 months. But like once we kind of figured it out, like it was the best decision I've ever made. But it's just getting over that initial, like taking that one foot and jumping in. But I definitely say having industry experience is huge. I worked for a consulting firm prior to this, so I knew the business model. I had contacts, so I knew what I was doing prior to that. But like I said, something I'd always wanted to do. I'm just waiting for like the right opportunity or the right time. So.
How do you see Nar evolving in the next 5-10 years, and where do you want it to evolve to?
Yeah, that's a good question, and something that we talk about quite a bit. Right now, like we've kind of set up sort of a 2- and 5-year plan where we'd like to grow to 50 engineers. That's kind of a good threshold for professional services. It's sort of the next level up. And one thing that I've discovered is I like working on larger projects, like 4+ engineering projects. I just find them to be more interesting. You can really immerse yourself. So like we want our portfolio of projects to all be of that size, and you need a team to support that, and not just engineers, but QA, PMs, things of that nature. So I think just as we scale and people count also scale and the nature and size of our projects. So.
Okay. Jack, Alicia, Megan?
And it said that there would be a red light.
I know you guys pretty much answered everything I was curious about.
So tell us something that you're going to take away from either of the presentations today.
Well, like I agree with like the Spotify thing, like how as soon as I go on my Spotify, like all my recent songs, and then like they automatically always give me recommendations on like new songs that I would be interested in, and like I always end up liking them. And then that's how I find my like new music, because Spotify literally like gives it to me, which is like exactly what she was talking about. And then also it was interesting because to hear about that the Nar company works with Whoop, because Whoop is like kind of like still smaller and not many people would know about it, but like I know a lot of athletes that use it, and like I've personally like used it before, and I just think it's like interesting how it all works together.